Okay, this is our video explanation for Unit 5, Lesson 5. What we're going to talk about today are first differences and second differences. You might remember first differences from when we did linear relations, but if you don't, it's okay. You'll catch up. No problem. So first differences are the difference between consecutive y values. So that's the first blank fill in. Consecutive means one after the other. So the order that the table is written in is important. And it's also important that we're talking about a table of values with evenly spaced x values. So if we look at our table that's down here and you jump from one x value to the next, they're always going up by 1. So they have to be evenly spaced if we want to talk about first differences and second differences. So for linear relationships, these are constant. So the consecutive y values, and for linear relationships, they will end up being constant. And what that means, and you'll see when we do this with our full table of values, what it means when we actually calculate the difference between one y value and the next, we get the same number every time. So constant just is another way of saying the same number. The second differences, you just do the same thing again. So the second difference is the difference between consecutive first differences. And if it's a quadratic, which makes that parabola shape that we've been learning about, if it's a quadratic, the second differences will be constant. So the second difference is the difference between consecutive first differences and for our quadratic relation, the second differences are also constant. That's the learning goal for today, is knowing that property, that for linear relationship, first differences are constant, and for a quadratic relationship, second differences are constant. But just knowing that doesn't mean you know how to answer the problem, so we're going to do some examples together. So this first one, before we even do our table of values, you know a lot about what the graph is going to look like because it fits this pattern from a previous unit where it looks like mx plus b. And when we graph something that's mx plus b, what we have is a straight line. So we know it's going to be a straight line before we even start. And in order to get this full table of values, we're going to plug in each value of x into the equation. And we're going to get our answer. So in this first row, we have an x value of -2 and a y value of -8. So we can write this as -2, -8. Before we start talking about the first differences, we're just going to plot all of the points that we got. So if you look at the first point, it's at x equals -2, y equals -8. And we'll just come across and plug them all. So -1, -6, 0, -4, 1, -2, and 2, 0. And you can see pretty clearly from our graph that yes, in fact, we did get a linear relationship. So we're going to connect that with a straight line. And so far, this is stuff that we did already. So we did that in a previous unit. You're really good at this. The new part is figuring out the first differences. So first differences, we're just going to look at the y values, and we're going to subtract the top one from the bottom one. So the first row, we don't ever worry about, so this next row is going to be -6 minus -8. So I take the current y value and I subtract the one before it. So for our calculation for the first differences, just to review that, we take the current y value, which in this case is -6, and subtract the one before it. So -6 minus -8. That's going to be the same thing as -6 plus 8, which will give us 2. And the next row is going to be -4 minus -6, which is the same thing as -4 plus 6, which again will give us 2. So if we keep going, the next one will be -2 minus -4, which is also 2. And the last one is 0 minus -2, which is also 2. So obviously, we notice that our first differences are constant. That's exactly what we said would happen up here. If it's a linear relationship, the first differences are constant. Constant is another way of saying you get the same number. So in part B, it says what do the first differences tell you about the relation? So the first differences tell us that the relation is linear because they are constant. So if we didn't graph the points, the table was enough to show us that it is linear. Just by looking at the first differences all being the same number, we know that what we have is a linear relationship. For our second example, I did the table of values for you. I know you're really good at doing table of values, so that's not the skill we're trying to practice today. We're trying to practice this first and second differences skill. So the table of values is already done for you. That's what's here. So we're just going to practice calculating the first and second differences. Notice the little arrows that are there? Those just remind us to take the lower number and subtract the number above it. So this first one here, we'll do the whole equation, and then after that, we'll just write the numbers. We're going to do 0.7 minus 0, which gives us 0.7, or just, I'm going to write 0.7 because I ran out of room. So 0.7 minus 0. What's the next one going to be?
2.9.
Brennan?
Minus 0.7.
Yeah, 2.9 minus 0.7. So you always take the lower number minus the top number. So we're going to go through and do that. I'm going to write the answers up here. Why don't you check maybe one or two, just to make sure you're getting the same number as me, but then I'm fine with you just copying them. We have our table at this point with all the first differences written in. Will we notice that it's not linear because they're not constant? So if they were all the same number, then it would be linear, but they're all different. Then we're going to calculate the second differences using the exact same strategy. We take the current number and subtract the previous number, and we're going to get 1.5. So you take the current number, so the next row would be 3.7 minus 2.2. If you grab your calculator and put that in, turns out you get 1.5 again. And it turns out that every single second difference is the same. And they're all 1.5. So now we have our list of second differences. They are constant. That tells us that the shape is going to be a parabola. So it's that quadratic relationship like we've been drawing. So it's either a smiley kind of face or a sad face, one or the other. If the second differences are constant, then it is a quadratic. So if we wanted to actually graph those points, we're going to do kind of a quick version of a graph here. The first differences are not constant, so we know that it's not linear. The second differences are constant, so we know that it is a quadratic. So what do we know? The relationship is a quadratic. So we're going to use this curve to estimate the initial speed of the car. The skid mark is 41 meters long. So we find out this spot at about 41 meters long for skid mark and follow it over until we run into our parabola. And then we go straight down to figure out the speed that would be. So this is just an estimate, so you don't have to stress about it being perfect, just sort of do a good job. And we're going to make an estimate here that it's about 72 kilometers an hour. That little symbol means approximately equal to. You could also do an equal sign with a dot on top. So it's 72 kilometers per hour.